Okay, now with that done, let's move on to the next part of the mind map, which is triangles. So now you can see we've started off with lines, then we went to angles, and now we are at triangles. A triangle is a polygon with 3 sides, 3 angles, and 3 vertices. Poly means many, and gon means side. So a polygon is a figure that has many sides. But a triangle is a polygon with 3 sides. So it has to have 3 sides. Right? Tri meaning 3, and angle means angle. So 3 angles. Right? The basic rules involving triangles are the interior angles of a triangle adds up to 180 degrees. So we can say that A1 plus B1 plus C1 must equal to 180 degrees. And the second rule is the exterior angle of a triangle is equal to the sum of the interior opposite. So we can say that C2 is equal to the sum of the interior opposite angles. So it'll be A1 and B1. So C2, angle C2 with the copy is equal to A1 plus B1. Understood? Then we categorize triangles according to either the angles in the triangle or the lengths of the sides. If you're looking at the angles, if we have one angle in the triangle that is equal to 90 degrees, then we call this a right angle triangle. If one angle is obtuse, then we have an obtuse angle triangle. And if one angle is acute, then we have a acute angle triangle. These are just ideas that you can use to expand your mind. They're not really necessary. But when we come to this part here, equilateral triangles and isosceles triangles, they are very significant. So when we categorize triangles according to their sides, if we have all sides equal, then we call this an equilateral triangle. If we have two sides equal in length, then we have an isosceles triangle. There's something very significant about this that I will mention just now. And if each side of the triangle differ in their length, then we call this a scalene triangle. And what's important to remember, because remember we said whenever two lines meet at a common point, what happens? They form an angle. So what we can conclude is that the largest side is always opposite the largest angle. So if you look at this triangle here, if this is the, so this is the obtuse angle. So this has to be the largest side. And if you look at something like a, right, and the smaller side is always opposite the smallest angle. So if you look at this diagram here, this angle is the smallest angle. So this side here has to be the smallest side. Very important to keep this idea at the back of your mind. It will link eventually. So that's the ideas of lines, angles, and triangles. Okay, so now let's move on to talking more deeply about equilateral triangles and isosceles triangles, because we will use them extensively in maths. Right, so now we're going to talk about properties and theorems. As I said, we're going to elaborate more on isosceles and equilateral triangles, but now I want to discuss them in terms of theorems. But there's something that you need to remember, that there's a big distinction between properties and theorems. Properties are the characteristics of a shape. In other words, what makes up the shape. With a theorem, we make use of a single property or a group of properties in order to use a theorem. So you'll see exactly what I mean as we discuss these two theorems here. On the previous page, I discussed the properties of isosceles triangles and equilateral triangles. Now I will discuss some of the theorems involving equilateral and isosceles triangles. As we said, isosceles triangles has two sides of equal length. So if you have a triangle, and if two sides are equal on those triangles, then you have what we call an isosceles triangle. An equilateral triangle has three equal sides. So if you have a triangle, and if three of the sides are equal, then you have an equilateral triangle. So if you notice what I said, I use an if and then statement. So you need to start thinking like this whenever we discuss theorems. If this, then what? If this, then what? So what the theorem does now, it took these properties and now it's going to give us some other conclusion about these shapes. So let's see what those conclusions are. We're saying if the sides of a triangle are congruent, then the angles opposite the sides are congruent. So this is what the theorem enables us to do now. It enables us to make some relationship between the side and the angle. So we would have not otherwise been able to do that. But now we can because of this theorem. Because the mathematicians proved it somehow. So now we can use the theorem. It has already been proven. So now we can use it when we're working with geometry problems. So if you think about the idea that we talked about earlier on, I said that the largest side will be opposite the largest angle. So then if these angles are the same, then these sides here have to be the same, isn't it? The sides opposite it. But now we're going in the reverse direction. We're saying if the sides are the same, then the angles have to be the same, right? So what we can say is that if the sides of a triangle are congruent, then the angles opposite the sides are congruent, right? Again, what did I say? If and then. Now, why is that important? Why is that if-then statement important? Because we talk about something called the converse. And what the converse does is we reverse the if and the then statement. So we take the if and we swap it around. So now what we can say, if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. Can you see that? So this is what we call the theorem. This part here is what we call the theorem. And this is what we call the converse. So we have the theorem and we have the converse. Understood? So let's look at the equilateral triangle theorem. The properties of an equilateral triangle is that all sides are equal in length and all three angles are equal and measure 60 degrees. Right? That's the properties of it. So what does the theorem state? It states that if, here's the word if, we have a triangle with three equal sides, then the angles have to be 60 degrees. And we can go in the reverse direction. If we have a triangle with all angles equal to 60 degrees, then the sides have to be equal. Understood? So this is the distinction between properties and theorems. Right, when we're solving questions, if you can somehow prove in a triangle that the three sides are equal, then you have an equilateral triangle. And if you can prove, or if it is given that a triangle has three equal sides, then what can we conclude about the interior angles? They are all equal to what? 60 degrees. Right, but what's the significance of this is that you could be given a triangle, an equilateral triangle like this here. 1, 2, 3. How many angles are here? There's three angles. There are three unknowns. How are we able to solve this? By making use of the theorem. That's the beauty of theorems, is that it enables us to do some complex calculations. So we don't have to go solve for these three angles. By the theorem, we can just conclude that they are 60 degrees. And mathematicians have already proven why this is the case. So again, if you're given the three equal sides, interior angles are 60 degrees. If you're given interior angle equal to 60 degrees, then we can say that we have three equal sides. That's what the theorem states. Right, and now I hope you see the distinction between a theorem and a property. With a theorem, we utilize a single property or a group of properties, and a property tells us what characteristics a shape has. Right, so this is the characteristics of it. But let's just say that we're given that all the lengths of the sides of the triangles are equal. Then what can we conclude about the angles? We can conclude that all the angles are 60 degrees. Let's say that we're given that all the interior angles of a triangle is 60 degrees. Then what can we conclude about the sides of the triangle? It is equal. Why? Because of the equilateral triangle theorem. Understood? So that's what these theorems enable us to do.